So, open web, next open web platform. About W3C, we making standards for the web, was created by Tim Berners-Lee in 1994. And we are global organizations. We have people all around the world. Not that many, but we do. And a lot of people are participating in groups. And you have groups from the HTML working group to groups you never heard or want to hear from. A little bit of W3C jargons. That's the W3C recommendation track. So it goes from working draft and series of working drafts. Then you go to last call when the working group thinks that they are done. And they'll publish the last call document. And we encourage review from everyone. And then when they address all those issues, they go to continuing recommendation. And we're waiting for implementation feedback. And once we are satisfied that, yes, we believe that the spec can be implemented and it can interop, and we have tests, then we move to proposal recommendation. And after that, it's a straight shot to recommendation in general. So if you take a specification like the HTML5 specification is still in the working draft status, we still have several open issues open against the document. In particular, lots of several accessibility issues that needs to be resolved before we can move the document to last call. So when we talk about the open web platform, looking at the history, at the beginning we had the web back in 1994, and that's a Yahoo page. And I used that slide several times already, so it's a perfect coincidence that actually I'm at Yahoo and I'm finally showing that slide here. And we only had 3 technologies: HTTP, URL, HTML, limited bandwidth, desktop only, and the only kind of interaction was we can click on links, and that was it. So very passive user experience. With the Web 2.0, which started around 2004 and still continue nowadays, we added more specification. We were able to do more. CSS got deployed, JavaScript as well, and Flash. Flash for videos, mainly nowadays. Everyone is installing the Flash plugin to be able to see those nifty cats videos on YouTube. We have a better bandwidth. Of course, we'll never get enough. And we have more computing powers. And of course, we'll never get enough. More devices. The arrival of the iPhone proved to everyone that it was possible to implement a web browser on a mobile phone, a full web browser. If you remember in the early days, 10 years ago, when we were saying at W3C we should make sure that the web technologies, we should apply the web technology to the phone, the response from the web forum was to create WML, because they didn't think that you can run a web browser on the phone. And well, we saw where it went, basically nowhere. Since then, they realigned themselves, and they are deploying web technology on the phone. So we have a more interactive user experience. We have blogs, vlogs, wikis, all kind of stuff now, and we can all have fun on the web and publish as well, which was, after all, the original vision that Tim had, that not only we should be able to actually get pages from the web, but also put content into the web as well. Except that what he had on vision wasn't exactly what happened from a technical point of view. So what's next? In W3C, we are pushing the web into different areas, into areas which are orthogonal. One is the web of data that refers to, of course, the semantic web, cloud computing that we are also interested in, mashups, data integration in general, and the other one is the web of interaction, how to improve the user interface that we have in front of us when we have a browser, and that's the second one that I'm going to talk about. So we started with HTML, what I would call the first generation web language, and we started to create several of second generation web languages, CSS, very early on, created at W3C, I believe back in 1996. SVG, we've been talking about it for all those years, saying it's going to be cool, guys. And guess what? It's going to be cool, guys. MathML, a much more narrow community out there, scientific mainly community, who is interested in putting math on the web. And you know, it's more slow, it's slower, but it's getting there. and a lot of other specification. A few, in fact, of other specifications getting there. So, you know, if I have to do a list of, okay, what is on the web and what is part of the whole next open web platform, well, here is a list with a dot, dot, dot at the end. I'm not sure I got all of them. In fact, I'm pretty sure I didn't get all of them. And the HTML5 specification is right there at the top. So someone at our last technical plenary showed up with a printed version of the HTML5 specification. And it was big like that. Like I don't know, several inches for sure. And my reaction to that was like, well, welcome to the club, because the HTML5 specification is big like that. Then you have CSS, then you have the web app specification, then you have HTTP, then you have a URI and so on, and you end up with a stack like that. So I'm not scared at all to have a big HTML5 specification, because it's only a small subset of what a web browser can do and need to do. So today I'm not going to go through every single one of them, because we won't have time for that. I picked and choose some of them, and I'm not saying that what I didn't pick is not important. It's just that I had to make a choice, unfortunately, for the interest of time. Not all of those specifications are done within W3C. And still, they are relevant for the web. I mean, HTTP, TLS, IRI, those are done within IETF. We are participating in those efforts. One of the editors of the HTTP specification is from the W3C staff, but those are not done at W3C. Another one like that is ECMAScript 5, which you guys should know a little bit, which is done within ECMA. And mainly for pure historical reason. At W3C, we were a little bit slow at understanding what JavaScript was really all about. Another one like that is the WebGL specification for 3D on the web, done within the Knosh initiative, because they are the one who did the OpenGL. And the last one on that list is the WebSockets protocol, which is done within IETF as well. We are doing the API part of it, but the protocol part is done within the IETF. So a little bit of quick and what I would call dirty history around HTML5. How did we end up there? So if you remember, back in the 1999 period, it was all about, we need to make sure that HTML is going to scale, that we're going to be able to do all kinds of extensions, and that's where XML came from, a merge between the HTML and the SGML communities. And in the process of doing that, we decided that's the way to go, and we stopped maintaining HTML. In 2004, we did a workshop on web application and compound documents, where we invited, okay, what's the future of web applications? And again, two communities went there, the HTML1 and the XML community. And I wasn't there myself, and the XML community won, to some extent, the debate there, and it was decided it's all going to be XML. Well, guess what? Apple, Opera, and Mozilla were at that meeting, didn't think that was the way, and wanted to be able to keep building on top of HTML. So they decided that W3C wasn't the way to go, and they created the WhatWG. And Ian Nixon, who used to work for Opera and now works for Google, and we all know each other in this very small community, I would say, started the effort of Web Application 1.0, which was later renamed HTML5. In 2007, W3C realized that we were making a mistake, in fact, and Tim Berners-Lee wrote a blog saying, yeah, we screwed up on that one. And we decided to have two efforts going in parallel, one which was the HTML working group working on HTML5, and the other one to continue the work on XHTML2. And finally, in 2009, in June last year, we announced that we are stopping the work on XHTML2. So while the XHTML2 working group still exists because they are doing some remaining stuff around XHTML 1.1 for the mobile industry, they are not longer working on XHTML2. And we may regret that decision later, but future will tell us. I certainly don't regret it so far. So what's the future of what is it between HTML and XML? So People thought when we announced that we were stopping the work on XHTML2 that we were stopping XHTML. Well, that's not true, because guess what? The HTML5 specification has two serialization, one which is HTML and the other one which is XML. So it has two syntax, in fact. And the way the parser works is dependent on the media type. If you use text HTML, you are in the HTML world, and you use application/XHTML plus XML, you are in the XML world. Almost all the browsers are actually implementing the XHTML MIME type except one. A little note, polyglot documents are documents that can be parsed both as HTML and as XML, and can be interpreted by the parsers in the same way as well. It's a subset of HTML documents, but it's also a subset of XML documents. There are some quirks around the parsing of the style and the script elements, for example. We are taking advantage of the XML platform. We are incorporating SVG and MathML into HTML5. It's part of the specification, normatively referenced. And another thing that is getting there as well is, for those of you who are used to have a specification talking only about the markup language, the HTML5 specs also contains a lot of API stuff there, including the DOM core, including the DOM HTML, but also a lot of extensions to various specific HTML tags. One of the debates which is happening in W3C, and it is not resolved, because it's kind of like those VI versus Emacs kind of debates. There is not necessarily a right answer, is decentralized extensibility. Some people would argue that the HTML spec is already extensible in a decentralized way because there is a little clause in the specs which says other applicable specification, meaning other specification can say whatever they want on top of HTML, which in fact no one can prevent that from happening. But there are various ways to extend extension point in HTML and in the XML serialization as well. The main difference is you can use XML namespaces in the XML serialization. You cannot use them at the moment, or in a very limited way, only for the purpose of SVG and MathML in the HTML serialization. And that generates a whole debate, because some people would like to have namespace support into the HTML syntax, serialization syntax, and some people don't even want to touch XML namespaces with a 10-foot pole. Another debate which has been happening more recently is around microdata and metadata and all kind of data, which is also another extension point for HTML5. So the whole question here is, how do we represent data in HTML so that we can then later on use this data into my web application or in order to do mashups between websites? And how do you integrate that data together? There are currently two proposals. One which is a microdata proposal, which was done by Ian Nixon, that he put it into the HTML5 spec. And then some people thought, well, it should belong in its own specification. And that was split out recently. It can let you do simple things in a simple way. It has an API so that you can use it in your applications as well. The other one in RDFA, it's based on semantic web. It lets you simple things in a complex way and complex things in a complex way as well. And it's using some form of XML namespaces. Yes, they don't even use full XML namespaces right there. The debate is still open. If you look at microdata, is pretty new, so it doesn't have any kind of deployment. Firefox says they are interested in implementing it. But the main consumers of those data in HTML are not going to be the web application of your own website. It's going to be other people who wanted to use those information for mashup and integration purposes. And RDFA is older and is seeing some deployment. The Google and the search engine, and the Google and the Yahoo search engine, in fact, are supporting some form of it. And the New York Times released last week a website, the data.nytimes.com, which contains the ontologies that they are using internally to classify all the articles that they have, so that their journalists can find them when they write new articles. And so they release a big ontology of 29,000 terms that they are using. And they linked it manually to Wikipedia and the geonames. And it's using semantic web technologies. So you can go from Wikipedia into the ontology of the New York Times and so on, and get information. And it also, you can download RDF information out of that. Another thing in the HTML5 specification is forms. What used to be web forms, it's now part of the specification. More types to do type validation, so you don't have to do that using JavaScript libraries. You know, it's pretty advanced. You know, you have range where you can even put a min and a max, whether this entry is required or not. Pattern, we let you do pattern matching on the value as well, whether there is one or multiple value that needs to be entered by the user, or could be entered by the users. Data list is actually a list of possible entries by the user as well. So it's more advanced. And we even have progress and meter. It's more advanced. However, you know, one of the questions people ask is how ready is HTML5? And well, it varies quite significantly between the parts in the specification. And HTML5 forms, I would not classify that in the stable parts at all. Opera started to implement it, and they're the only one at the moment. And we're willing to bet that as soon as the others are going to start looking into that, they're going to probably find stuff that they want to change. So I would be careful with that section. Of course, you are also welcome to review it and provide feedback as well. I didn't see a sense of urgency from the, beside Opera, we implemented it. I didn't see a sense of urgency from the others to actually implement that part either. So that's not, I would not put that into the things that is stable. In contrast, you have the HTML5 video element getting a lot of tractions. Opera was the first one to send a proposal back in 2008. We need to make, if you remember, O'Conley was pushing to make video the first-class citizen of the web. The same way as we can link images on the web, why can't we link video on the web as well? And it's there. There is a video element tag, and there is an API that goes with it, so you can actually take advantage of your applications. So if you look at something like that text contains some JavaScript underneath, so when you click on vid.play, it basically using a JavaScript call to say, well, video play, and it's playing. And because it's perfectly integrated, I can use CSS opacity on it. We don't have to reinvent a new opacity value just because it's a video. And the ZDDEX lets you put text on top of the video or under the video if you want to. And works. That's getting stable, I would say. The stop we had, for example, a year ago, we had a stop function on it, which got removed. 2 weeks ago, on the other hand, there was a discussion regarding the auto buffer attribute, and people realized maybe that's not exactly what we need for use cases. So it's very likely that the auto buffer attribute will be replaced by something else at some point. So even there, it's not 100% stable. And there is a big dragon lying around video. It's what format are we going to settle on? And well, there are plenty of video format, video codecs out there, plenty of audio codecs, and plenty of format container. And if you look at current implementations, you'll find that Safari is implementing the video element using the MPEG-4 format, and also let you use other formats if you happen to have them supported by your QuickTime engine on the platform. Firefox is implementing Oxiora format, and while they don't support other formats at the moment through extensions API, I believe that they are interested in doing that. Opera is also supporting Oxiora and also other formats through extensions API that is available on the platform as well. So you know, we guarantee to have MPEG-4 in Safari. We guarantee to have Octheora and, supported in Firefox and Opera, but we don't have Opera. Theora is not supported by Safari. And MPEG-4 by default is not supported by Firefox and Opera. And the reason is because there are dragons lying there around the requirements for a video codec, in particular regarding the IP. It's not really a technical problem here. It's really IP related. And you know, MPEG-4, there is a licensing. There are licensing terms around MPEG-4. You're not supposed to provide an MPEG-4 decoder open source like that, so it's a problem for Mozilla. They want to have a codec that they can actually fit their open source development model, so they can put the code into there. And Apple said that they are not going to support Octheora because they are fear of submarine patents that might affect the format. The XIF Foundation behind the Octheora format is not aware of any, but they are not able to prove that, of course. There is no official legal study on Octheora to be able to say that. And so that still remains a problem. And for an organization like W3C to be able to resolve that, it means that I'm going to have to put lawyers around the table and ask them the question, can we use Theora? And if not, what are the patents that are impacting the format, if any? Or I have to go and try to negotiate with the MPEG-4 to try to get the baseline profile royalty-free. And when it comes down to that, it's like, so you have MPEG-LA who is doing the licensing of MPEG-4, but there are only a subset of the patent holders around MPEG-4. So it's not only MPEG-LA, but it's also other companies that we might not know. So that, as long as this problem is not resolved, it will certainly get in the way of the deployment of the HTML video element. Switching to CSS a little bit. And where are we with CSS? So the group hasn't been publishing anything major, any new recommendation for the past 7 or 8 years. They are still active. They've been working for the past 7 or 8 years. And there is still a lot to do. But they recently published a set of candidate recommendations that they believe are going to be ready for testing. They've been trying to wrap up CSS 2.1 for so many years that I stopped counting. And the main problem with CSS 2.1 is not that we don't believe the spec is ready, is we don't have a major test suite. And that's one problem. And we know that it's not fully implemented by any of the browsers out there. IE8 is probably the one who is doing the best on it, and we can't prove it. And so my take is we're going to have W3C has to release CSS 2.1 and be done with it, knowing that, yes, we don't have 100% implementation of it, but the remaining of the browser vendors are not really interested in going into all the corner cases that you have in CSS and resolve every single one of them to make W3C happy. And in the meantime, a lot of the browsers are more interested in the new features of CSS3. In fact, Apple, for example, back last year, submitted new modules around CSS, transformation, 2D transformation, 3D transformation, and animations. And let's face it, if you've seen any of their demos around CSS animation and transformation, when can I use it? That's the best answer you can get. That's the best question you can make. It's pretty nifty. I picked a few CSS specifications that went to CR recently and are getting there. CSS3 selectors, if you ever try to actually style a table, you realize that you need to put a lot of CSS classes or attribute or ID element into your table so that you can address each cell on the table in order to style it. That table doesn't contain any of that. It's totally styled using CSS3 selectors outside the table. And you can address rows, you can address columns pretty easily. For example, you don't have a border on the side right there. It's just to say TD first child, don't put a border on the left, and that's it, one selector. If you wanted to do that without CSS3 selectors, you would have to put a class attribute on every single one of those cells to be able to do that. There are still, of course, things that are not that easy to do. This effect around this column red highlighted, it still requires 4 CSS selectors to do it. And that's because HTML tables are represented in the markup as rows and not columns. That's the main reason why. It's not that because CSS is stupid, it's just that, well, I mean, there is no concept of columns in the tree itself, in the HTML tree. And you'll see that on the way, I'm using CSS3 colors and with an opacity on it. That's actually on the color itself. That is the opacity. Another one which is getting there is CSS3 borders. You can basically use either a border radius, and in the alpha version of Opera 10.5, they actually drop their prefix, because since this went to CR, the agreement in the CSS working group is as soon as a spec go to CR, you are allowed to actually use the real name of the property and not add -moz or -webkit or -o in front of it. So they actually drop the prefix. They still support it so that previous content will work, but you are now, if you put border radius, that will work in Opera 10.5. And we can expect the others are also going to follow as soon as they release new versions as well. Border images is also there. It works pretty simply. You have an image which is divided in 9 parts, and you can control how the division is happening. And then you indicate whether you want those parts to be stretched or repeated like that. And this is the kind of effect you can have when you combine all of that, and plus you add fonts. Fonts is one of those subjects that has been talked in W3C for the past, 12 years, 13 years, and that we never managed to resolve. So if you try that page in all the browsers, you will not get the borders, for example, in IE, but you will get the right font. It will, including in IE6. The text itself will be rendered with the appropriate font, including in IE6. And it's because CSS font face as a fallback mechanism. So even if IE at the moment supports COT, they've been supporting it since IE6 or IE5. Firefox, Opera, and Safari/Google have been supporting through typed TTF and not TTL, and OpenType OTF. And last year, 2 formats emerged. One was CWT, which is a lighter version of EOT, and WOF, Web Open Font Format. Both were actually created by Mozilla. The specs were issued by Mozilla, both of them. And WOF is getting a lot of traction. It's probably the one who is going to be deployed in everything, supported by all the browsers in the long run. CWT, I do not believe that CWT is going to get a lot of traction. While some of the companies are interested in implementing it, I don't believe they will all do it. So we are in the process of setting up a working group to work on fonts. It will mention both the CWT and the WOF formats in it, but I believe that in the long run, CWT will be forgotten for WOF. Everyone is interested to support WOF at this time. And the font vendors are also interested in being able to use it. Talking about SVG. So yes, as I told you, we've been talking about how great SVG is for the past 10 years. I'm exaggerating a bit, but only a bit. But it's getting there. That's the good news. It's referenced by the HTML5 spec. Opera supports SVG 1.1 and SVG 1.2 for quite a long time. I mean, SVG 1.2 was released recently, but they've been supporting SVG for quite a long time. And the main reason is because SVG was deployed a lot on the mobile platform in Japan. Firefox and WebKit also support most of SVG 1.1. I would say that WebKit still have some filters to implement and stuff like that. So there are some dragons in terms of interrupts there. If you produce an SVG, you need to be careful a little bit there. But they are getting there. Microsoft joined the working group 2 weeks ago. They didn't say why. They joined the working group 2 weeks ago. And if you want to know why, you are welcome to go and ask them, of course. Authoring tools are getting better as well. Inkscape is one of them, an open source authoring tools for SVG. A lot of people are starting to use it. And if you produce some document in SVG in Inkscape and you paste it into Firefox, it has a good chance it will work out of the blue like that. So the good news is we're getting there. We are certainly getting there. There are the other kind of dragons that you're going to run into is if you take, like, for example, Firefox, and you try to put SVG into an HTML document, it's not going to work. If you try to put SVG into an XHTML document, it will work, on the other hand. So the HTML5 specs tell you how to put SVG inside HTML, but it's not there yet. It's not, they haven't implemented it. And that's going to be the same thing with Opera and the same thing with WebKit as well. If Microsoft ever implement SVG one day, they haven't been supporting XHTML so far. It's going to be interesting what they're going to do in that space. There might be a little bit of easy irony where they're going to support it into the HTML syntax, and then you will have to face with the problem. Well, if I want it to work with Firefox, it has to be XHTML, and if I want it to work with IE, it has to be HTML. So we're not fully done yet, but we're like getting close. So I'm going to show you some demos of what you can do once you have a spec like HTML that includes SVG. So that's actually the HTML, again, the HTML5 video element. And around it, or actually precisely underneath, this bar right there, it says SVG. It's an XHTML document. If you try to load the same document as HTML, you're not going to see the bar at all because Firefox is not going to interpret the markup as SVG. But that's SVG, and indeed, and it works quite well. If you click on the play button, it will play the video. There is captioning on it. Firefox does not support captioning, and I did a library to convert time text captions into HTML, and using CSS, I'm displaying the caption at the right time by listening on the time update event coming out of the video. Same thing here, it's listening to the on-time update event coming out of the video. So when I click on the play button here, what it does is say to the video, play, and in return, the video tells the SVG, I'm playing. And which means that if I show the controls, they all come with default controls that you can show if you want to in Firefox. And if I show those controls, you'll see, well, they're acting exactly the same way, because those controls are also implemented using the API inside the HTML5 spec. So if I pause that one, both interfaces are reacting the same way. Or if I mute it, they're all going to react the same way as well. And it's all done using JavaScript. So that's one example of what you can do. Another one is this. Take the previous slide with the video, put it into an iframe, and apply an SVG mask on it. That's what you get. Suddenly you have the SVG mask, which is applied in real time by Firefox on the iframe. And that works perfectly well. And since this is a previous slide, if you actually switch and go to that slide, then you have the slide within the slide. And I don't know how many times you can go like that without crashing Firefox. I'd be curious, actually, if it crashed or not. It might not. Another example is this, the Gaussian blur article. I took an article out of Wikipedia, and I wanted to show that you can write it using almost as only HTML, SVG, and MathML. There is only one image, one ping image in that document, and it's right there. It's the one where you have an eye on it. And the image underneath with an eye, but this time blurred, is done by Firefox using SVG. So all the blur effects here are applied using Firefox. The image of the flag, Commonwealth flag, is a big one, a 1600 by 800 SVG, which I'm downscaling so that it can fit, and I'm applying a blur effect on it. And it's all done using Firefox. The math here is all MathML. If you actually go on the Wikipedia article, those are images. And the thing which is happening right now, which is that Firefox is splitting the formula on 2 lines because it cannot display fully on one, that you wouldn't be able to do that with Wikipedia because they're using images. And same thing over there, this little formula is also splitted as well. And if you use content editable attribute from HTML5, you can actually and attach the attribute to a paragraph or a span. You can say the user can edit this, and you receive an on-change event if the text is changed in that. And in that case, I can do that, and I can change the text, and it's using JavaScript. It's changing the blur effect within the SVG as well. And by the way, this document is using CSS multicolons effect. So if I take this and I make the window a lot smaller, then Firefox is showing the document only 1 column. That's all done by Firefox. That's my stress test, I would say, document, because if you see here, you have a matrix which is not displayed properly by Firefox. They don't support MathML matrix here. If you try that document in WebKit, the math is not going to show up. They don't support math yet. Opera is going to do a good job at it, especially Opera 10.5. Except I don't believe they support the matrix either. But if I try it on my phone with Opera Mobile, the SVG is going to work. Except they don't support the content editable attribute. But the SVG is going to work just fine. So it's getting there. So another slide I like to show is that one, what I would call my ugly slide, the one that tells you that you don't want to hire me as a web designer. If you put all those technology together on one slide, this is what you would get. So this time I'm using CSS transformation, which is supported in WebKit, supported in Firefox, and it's supported in the alpha version 10.5 of Opera as well. And you will get, besides the position of the elements, which I did it as a quick and dirty, you will get the exact same rendering in all of those trees. And so you have HTML5 buttons right there. This is not something you were able to do with HTML4 to actually be able to put span element on the text of your button, and you can rotate all of that. So if I click on this button, a little JavaScript is going to change the CSS transform property and rotate my button. Because the MathML is inside the tree, if I click on this button, I can go using the pure DOM core functions and go and change the math formula as well, which is tilted using CSS transformation. There is an SVG in the page, and I can go there in my input text field in HTML, and using one line of JavaScript, I can go and, if I get the focus, no, I was not pressing the right button. I can go delete that, and I can change that. And it will work. And because the SVG is part of the tree, if I change the value of the Gaussian blur element, then I can actually change that as well. There is a video on that. You can play the video. It will play the video while it's being transformed as well. But I can put some JavaScript, and if I want to, I can actually rotate the video while the video is playing. Why not? You might want to use this very often, but so going into a list of other things that you might want to look into. 2D context. That came out of Apple originally. It's the canvas element in HTML5 gives you a graphic context in the HTML page, And then using the 2D context API, you can actually do 2D drawing operations there. If you use the WebGL API, you will be able to do 3D operation there. And it's, what you're doing is drawing on a bitmap. So if you compare that, if you wonder, what is the difference between SVG and Canvas 2D? Well, it's with the Canvas 2D API, what you will do is you can do bitmap operation. You are just drawing. If you don't remember where your drawing stuff, you won't know where it is. But you can do some pretty stuff if you want to manipulate at the pixel level. So for example, during the Google I/O conference last year, they did a presentation of, they were copying the content of a video inside the graphic context. So the video was playing within that context, and they were doing face recognition inside that area. That's something you will not be able to do with SVG, because you cannot access the pixel level in SVG at all. On the other hand, when I was changing my blur effect on the previous slide, I wouldn't be able to change my blur effect here because I drew it already. I cannot just say delete what I just did or undo it. It was drawn on the page. So different use cases, and for example, it really depends on what you want to do there, whether you're going to pick SVG or the 2D API. An example of a 2D API is this, which I didn't do myself, but you can draw on the page on this that contains the canvas element, and you draw on it. And if you stop it, here in this case, this little demo is remembering the mouse events and replaying them at the right time as well. There is another demo which I don't have here, which is the SVG edit one, which lets you do, which is an SVG editor as a web application. And it's using the Canvas API as well for you to draw, except that it will later convert what you just draw into an SVG document. One thing that I think that everyone should look into is, or watch at least that space, is the WebSockets. So the use case is you have an application online and you need to update it on a regular basis, whether it's because it's in email or you're doing real-time collaborative editing. And right now, you don't have a lot of solutions to do that except using the XHR object and pulling the server at regular interval to try to actually guess, okay, see if there was any updates since last time I checked. Well, it could be quite consuming on the server, and the WebSockets is there for the rescue. So it's basically making an HTTP 1.1 request to the server. And there is a feature in HTTP 1.1 which has been there for a decade, which is called upgrade. And you're basically asking the server, can you please upgrade me to something else, to another protocol? Whether it could be IRC protocol or whatever you want. In this case, you're telling it, upgrade me to the WebSockets. And after a few handshakes like that, what you basically have is a TCP connection with a server. So now you don't have to send plenty of HTTP headers every time you requesting something from the server, and the server doesn't have to wait for you to tell you that there was an update. It can just send those to you as well. So that is going to be used heavily in future web applications. I believe, and I'm not quite sure, that WebKit is implementing that, or has some versions of it, at least. Firefox was looking to implement it in Firefox 3.7, but now that they said they're not going to release 3.7, it might be a 3.6 point something. I'm not quite sure about that. There are still some security issues, so that's why I'm saying on this slide, subject to origin constraints, and it all goes into the cross-origin problem that we already have when we try to do, if we want to do mashups between multiple websites. But it's going to use the same solution in that space. I forgot to change the title of the slide, but here I'm talking about web workers. It's multi-threading in your JavaScript applications. You're basically creating a worker, say the task is inside this stuff, and using the eventing system, you will be told when the results arrive through the post message API, which is also used to do communication between frames. So I was showing earlier some HTML documents, some XHTML documents, some XHTML document with SVG. So let's go the other way around. Let's go an SVG document with some XHTML inside. And so that text right there is SVG. You have an HTML table right there, and you have, of course, an SVG here. Unfortunately, I'm not going to be able to run this demo in front of you because I'm not connected on the network. So I'm going to have to describe what's happening. And you're going to have to use a little bit of your imagination. So when I click on this button, it's making a JavaScript call requesting the GPS location of the web browser. And what Firefox, in this case, is showing you is a little toolbar which says, do you want to share this location with this application, with this website, in fact? Because once you give the GPS location back to the JavaScript, that's it. The JavaScript can do whatever it wants with it, including sending it back to the server where the JavaScript came from. And if you say yes, then it will return. So it is a callback mechanism. It will return the GPS location into the JavaScript to the application. So if I was on the network, what you would see happening right now is that would be replaced with the approximate GPS location of my laptop. And here, this logo would be replaced with a Google map. A real Google map that you will be able to zoom and slide on the side if you wanted to. That's HTML within SVG. How does it do that? How does it know where my laptop is? I don't have a GPS device on my laptop. And the way Firefox implemented it is using Google Latitude. They are basically sending your IP address to Google, which in return gives them a GPS position. So it's not always that precise. So moving a little bit more away of what some people would put into the classification of HTML enhancement, there is another entire space about deploying web application as standalone application, not necessarily just in the web browser. In the mobile space, for example, there is a lot of interest in deploying application using web technologies. And you need to be able to do a lot more, to access a lot more information than what you can do with the current web APIs. You want to be able to access the calendaring, task, contacts, camera, all kind of stuff that you can imagine. Is my system online or offline? You know, is it the right time so that can I use a network connection? All those kind of stuff. So there is a group in W3C working on device APIs. And they just started the work 2 weeks ago. No, sorry, 2 months ago. And when we talk about deploying standalone applications, well, we need to have a way of packaging our application so that the users download one file and suddenly has the application installed on his system. And that's what widgets are from. It's basically a zip file which contains all your HTML, CSS, JavaScript, and images. Whatever you want to put in it, that your web application, which is going to run as standalone, is going to be able to use. And you can imagine it's using a lot of the HTML5 features, like, you know, I didn't talk about web storage, but web storage is used by the widget API as well. So that's a screenshot of my desktop using Opera widgets, which is not quite yet an implementation of W3C widgets, since they were pretty early on that, but it's all using HTML, CSS, and JavaScript right there. And if you take this Twitter application and put it on my phone, this is what you get, the same application running on my phone. W3C widget is getting deployed. For example, the latest version of Windows Mobile will have built-in support for W3C widgets. And certainly Opera is going to look into it. Nokia is also interested to deploy that on their mobiles and have a store also that they can actually sell also applications using that as well. There was one interesting announcement which I've been waiting for the past year and a half, last week at the CES conference that happened, where we have now our first implementation of W3C widget in an IPTV set-top box. As you can imagine, everything which is happening right now on the mobile in terms of deploying applications, it's going to happen to television. And you guys at Yahoo know a little bit about that, since you've been doing some work in that area with Sony already. And you know, almost 2 years ago, I was in South Korea, and and they showed me a television that has support for HTML right there, without having the need for an external box, and it was able to show widgets, not W3C widgets 2 years ago, but widgets in HTML. The television was plugged to the internet and downloading the widget from a central server managed by Samsung, actually. And Verizon is looking into deploying more and more widgets on your television, so you can tweet or whatever you want to do while watching a show as well. So it's not going to be longer only restricted to mobile. So how can you participate? We have mailing lists. We have workshops, even if there are none of that area that are currently going to happen. Join the working groups. When it comes down to HTML and CSS, my biggest worry is like, how do we test all of that? If we want the people in the street to be able to use that, we have to test. And we should not only test HTML5, we should not only say CSS 2.1, we should not only test the geolocation, we should test them all together. Because that's how we are going to use them, all together. And that's one thing that I like W3C to do a lot more, is testing and improve the testing around those specifications quite a lot. If you want to make a specification like HTML5 successful, we have to test it and test it as much as possible. And that's it. Those slides are available online. You can go and see them, look at the code as well, and try those slides in different web browsers to watch, to see the differences. Some of them will not work. Some of them will work or kind of work. But feel free to go and look at them, for sure.